Welcome back, everyone, to the deep dive. So today we're looking at how to choose the right database service on AWS. You've given me some great material on PostgreSQL RDS and Redshift, including this article by Tomer Ben David that really digs into pricing. What's the mission for our deep dive today?
Well, I think it's easy to get caught up in initial cost comparisons, but like many things in technology, a deeper dive reveals a lot more to consider. We're going to try to unpack those nuances today.
Okay, so let's start with the basics. We're talking about RDS, Amazon's managed relational database service, often used with PostgreSQL and Redshift, their data warehousing powerhouse. Think e-commerce transactions on one hand and massive scale analytics on the other.
Exactly. RDS with PostgreSQL gives you that classic relational database setup, great for applications that need ACD compliance and rock-solid transactions. It's a workhorse for a lot of businesses. Redshift, on the other hand, is purpose-built for handling huge data sets and complex queries, the kind of stuff that makes business intelligence analysts drool.
So let's talk money. Tomer's article dives into the pricing models of both services. For RDS, it seems pretty straightforward. You've got compute costs, which depend on the size of your instance, and then storage costs, paid per gigabyte each month.
Right, it's like renting a server in a storage unit. The more powerful your server and the more space you need, the higher the cost.
Tomer uses a db.m5.x large instance with 1 terabyte of storage as an example. That comes out to about $405 a month, $280 for compute, and $125 for storage. Now, Redshifts pricing gets a little more interesting.
You can choose between on-demand nodes, similar to how RDS instances work, or you can go serverless, where you pay per Redshift processing unit, or RPU, per hour. That serverless option scales up and down with your workload, which sounds handy but can be tricky to manage.
And then there's Redshift's storage cost, which Tomer points out is remarkably low, only 0.024 subs per gigabyte per month. Looking at his examples, a DS2.x large on-demand node with 1 terabyte of storage would cost about $973 a month, $949 for compute, and just $24 for storage. Serverless with the same storage comes in at $11,119 per month.
Now, you might be looking at those numbers and thinking, RDS seems like the clear winner, especially for smaller data sets. And that's a fair initial reaction. But we need to dig deeper and consider the why behind those costs. Why is Redshift storage so much cheaper?
Good point. I'm guessing it has something to do with how each service is designed and what it's optimized for.
Exactly. Redshift's architecture is fundamentally different from RDS. It uses columnar storage, which means data is organized by column instead of by row. This is incredibly efficient for analytical queries because you often only need to access specific columns rather than entire rows. Add in Redshift's compression techniques, and suddenly you've got a system that can store massive amounts of data in a very compact way, hence the low storage cost.
So it's not just magic. There's a reason why Redshift can offer such attractive storage pricing. It's all about efficiency and optimization for specific tasks.
And this difference in architecture has significant implications for performance too. Redshift is designed to handle complex analytical queries across massive datasets, and it does so by leveraging parallel processing. Imagine a team of analysts working simultaneously on different parts of a problem. That's kind of how Redshift crunches data, distributing the workload across multiple nodes to get you answers faster.
Okay, so it's becoming clear that while RDS might seem cheaper upfront, Redshift's low storage cost and optimized architecture make it a serious contender, especially for data-heavy applications. But when does it actually become more cost-effective? Where's that tipping point where Redshift's advantages outweigh the initially higher compute costs?
That's the million-dollar question, and unfortunately, there's no simple answer. It depends on a lot of factors. The size and complexity of your data sets, the types of queries you're running, your specific workload patterns, and even your tolerance for managing variable costs with serverless. That's why it's so important to look beyond those initial price tags and understand the underlying reasons behind them.
All right, so we've laid out the basics of pricing and architecture for both RDS and Redshift. But what about those hidden factors we mentioned? The stuff beyond just dollars and cents.
That's where things get really interesting. Let's explore some of those considerations next.
We just dug into the nuts and bolts of pricing for PostgreSQL, RDS, and Redshift, and it's clear there's more to the story than just those initial numbers. What are some of the other factors that might make one of these services a better fit for someone?
Well, I think security is a big one. Both RDS and Redshift offer robust security features, but their approaches are tailored to their respective strengths.
Okay, so how does that break down? RDS is all about those transactions, so I'm guessing security is pretty tight.
Exactly. With RDS, you've got fine-grained access control, data encryption at rest and in transit,
Yeah.
and integrates well with AWS's broader security tools. It's like having a bank vault for your data, with multiple layers of protection to ensure only authorized users can get in.
So if you're handling sensitive information like financial transactions or healthcare records, RDS sounds like a solid choice. What about Redshift? With all that data for analysis, the security must be a top priority there too, right?
Absolutely. Redshift's security focus is on protecting large data sets and making sure the right people have access for analysis. It's more about controlling access at the team or departmental level rather than individual users.
So instead of a vault, it's more like a secure research lab where authorized teams can collaborate and dig into the data.
That's a great analogy. Choosing between those two security models really comes down to what you're trying to achieve and the sensitivity of your data. If you need that granular control at the individual user level, RDS is likely the way to go. If it's more about enabling secure collaboration and analysis within teams, Redshift's approach might be a better fit.
Another thing that always comes up is ease of use. Nobody wants to spend weeks wrestling with a complex system just to get started. How do RDS and Redshift stack up in that department?
Well, both services have become much easier to manage over the years. RDS is generally considered more straightforward, especially for those familiar with traditional database administration. It's like driving a car, you know where everything is and it just works.
So for someone comfortable with databases, RDS would feel like home.
Mhm.
What about Redshift? Has it shaken off that reputation for being a bit more complex?
It has to a large extent. Features like serverless deployment have been a game changer, eliminating the need to manage nodes manually.
Yeah.
And AWS has really simplified the process of loading and preparing data for analysis.
That's great to hear. It sounds like they've made Redshift much more approachable, even for those who aren't data engineering wizards. But speaking of serverless, didn't you mention earlier that it can be a bit tricky when it comes to cost control?
Yeah, that's the trade-off with serverless. You get incredible flexibility, but you also need to be more vigilant about monitoring your usage and understanding how your costs might fluctuate. If your workload suddenly spikes and you're not paying attention, you could end up with a bigger bill than you expected.
So it's a powerful tool, but you need to use it wisely. Kind of like having a car that can transform from a compact for daily commutes to a spacious SUV for road trips. But you really need to keep an eye on that fuel gauge to avoid any surprises.
Exactly. Now, beyond security and ease of use, another crucial consideration is integration. Both RDS and Redshift play well with other AWS services, but their strengths lie in different areas.
This is where things get interesting. It's not just about the services themselves, but how they fit into a larger ecosystem. What kind of integrations stand out for each service?
Well, RDS, being a general-purpose database, seamlessly integrates with tools for application development, web frameworks, you name it. If you're building applications that need to interact with a database, RDS makes that connection smooth.
So it's like the universal adapter that can connect to all sorts of devices and platforms. Makes sense given its role as a workhorse for various applications. What about Redshift? Where does it shine in terms of integration?
Redshift is all about the data analytics and business intelligence tools. Think data visualization platforms, reporting tools, machine learning services. Redshift can easily feed data into those systems to help you extract valuable insights.
It's like a pipeline connecting the data warehouse to the tools that make sense of it all. RDS for building applications, Redshift for analyzing data. Choosing the right tool for the job is key.
Precisely. And speaking of the right tool for the job, you mentioned earlier that Redshift has become more approachable. But is it truly accessible to everyone? Does someone need a specialized data engineering background to really get the most out of it?
That's a great question. While those improvements have definitely made Redshift easier to use, it's still primarily geared towards data professionals and organizations with data engineering expertise. It's not something you typically spin up for a personal project or a small-scale application.
However, the rise of serverless Redshift and the growing ecosystem of tools and services around it are opening doors for a wider audience. It's like learning to fly a plane. It used to require years of training, but with advancements in technology and flight simulators, more people can get behind the controls. You still need to learn and put in the effort, but the barrier to entry is lower than ever before.
That's a great analogy. So choosing between RDS and Redshift isn't a simple yes or no answer. You need to think about your data, your budget, your security needs, your team skills, and how these services fit into your existing workflows.
Exactly. We've covered a lot of ground here, but there's always more to explore. We've just scratched the surface of what these powerful services can do.
That's the beauty of the data world. It's constantly evolving, and there's always something new to learn. But don't worry, we're here to help you navigate it all. Now, before we wrap up this deep dive, I want to leave our listeners with a final thought provoking question. We've been unpacking the choice between PostgreSQL RDS and Redshift, and honestly, it's been eye opening to see how much goes into making that decision.
It's easy to get caught up in the technical details, but what's really exciting is the bigger picture, how these services are shaping the way we think about data and its potential.
Okay, I'm all ears. How are these services changing our approach to data?
Well, think about it. Cloud-based services like RDS and Redshift have democratized access to data. You don't need massive investments in hardware or complex infrastructure anymore. It's all there in the cloud, ready to be tapped into.
It's like having a library of knowledge at your fingertips without the dusty books and cramped reading rooms.
Exactly. This accessibility is driving a data-driven revolution across all sorts of fields. Businesses are using data to understand their customers better, optimize their operations, and make more informed decisions. Researchers are leveraging data to uncover insights and solve complex problems. Even individuals are using data to track their fitness, manage their finances, and basically make more informed choices about their lives.
It's amazing to see how data is becoming so ingrained in everything we do. It's not just a technical concern anymore, it's a fundamental part of how we live and work.
And we're just getting started. As these technologies continue to evolve, we can expect even more profound changes. We're moving toward a future where data isn't just accessible, but understandable, actionable, and ultimately empowering.
I love that empowering. It's not just about crunching numbers, it's about using data to make a positive impact.
Absolutely. And that's why choosing the right tools is so crucial. RDS and Redshift are more than just technical solutions. They're enablers of innovation, discovery, and progress. By understanding their strengths and limitations, we can really harness their power to shape a better future.
Well said. We've gone deep on pricing, security, ease of use, and integration. We even touched on how these services are changing the data landscape itself. But before we wrap up, I do want to circle back to something you mentioned earlier, the idea of blurring lines between transactional databases and data warehouses. Is that just a pipe dream, or is it a glimpse into the future of data management?
That's a fascinating question, and one that sparks a lot of debate in the data world. Imagine a world where you can seamlessly query massive data sets while still maintaining the transactional integrity and ACD compliance of a traditional database. It's a tantalizing prospect, but it comes with its own set of challenges.
I'm guessing those challenges have a lot to do with performance and complexity. Maintaining that balance between massive scale and transactional consistency has got to be tricky.
You're absolutely right. There are inherent trade-offs involved. Traditional transactional databases are optimized for high-frequency, short-lived operations. Data warehouses, on the other hand, are designed for complex queries over massive datasets. Bridging that gap requires innovation in database architecture and query processing techniques.
So it's not impossible, but it requires a significant leap forward in technology. Are there any signs that we're moving in that direction?
Well, we're already seeing glimpses of it. New database technologies like distributed SQL databases are emerging that attempt to combine the best of both worlds. Cloud providers are also innovating rapidly, pushing the boundaries of what's possible with services like RDS and Redshift. It's an exciting area to watch, and I have no doubt that we'll continue to see advancements that blur those lines even further.
It sounds like we're on the cusp of a major shift in how we think about and interact with data. Exciting times ahead. And with that, we've reached the end of our deep dive into PostgreSQL RDS and Redshift. We hope you've enjoyed the journey and gleaned some valuable insights along the way.
Remember, the world of data is constantly evolving. Keep exploring, keep asking questions, and keep pushing the boundaries of what's possible.
And a big thank you to Tomer Ben David for his insightful article that sparked this entire conversation. If you're interested in diving deeper into the world of data, be sure to check out his other work. He's a wealth of knowledge.
Absolutely. Tomer's work is a valuable resource for anyone looking to navigate the complex and ever-changing landscape of data management and analytics.
Until next time, keep diving deep.